Okay, so the nice thing about 2.3 is basically we're just going to be using graphs, using tables to determine whether or not something is a linear function. So all we really have to do is say, yes, it is, no, it's not. You don't even have to write the rules for it. But I want you to have some practice so that we can see the differences between what a linear function looks like in a table and what it looks like, because you know what it is on a graph, right? So look at problem 1. The area in square inches of a pizza is a function of its radius, r. Graph the function shown by the table. Is it linear or nonlinear? What is our input in this case? The radius. And it's being measured in inches, so we have to label it inches. What's our output? The area, and it's inches squared. Okay? So I'm going to, along the x-axis, every line is going to be 1, but I'm only going to label every other one. So 2, 4, 6, 8, and I'm going to go to 10. Now, for the area, they do start to get really big, so I'm going to count by 20s. So 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. And then we're just going to have to do our best at estimating for the graph, okay? Okay, so according to the table, if my radius is 2, the area is 12.58 or 57. So here's 2. Remember, the first line is 20, so 12 is going to be somewhere right here, kind of in the middle. When my radius is 4, the area is 50.27. So here is 20, here is 40, and then 50 is going to be somewhere in between 40 and 60. When my radius is 6, the area is 113.10. So that's 20, 40, 60, 80, 100. And then 113 is going to be somewhere right here. When my radius is 8, the area is 201. So I'm just going to put that really, really close to 200. Are you guys okay with that? Like practically on top of it. And then the last one is when my radius is 10, the area is 314.16. So that's going to be 300, and 314 is going to be somewhere right here. Question to all of you. Is this going to be continuous or discrete?
Continuous, because there's decimals in
Okay, Ariana says continuous because there's decimals. It is continuous. There's another reason why. What is our input?
Radius.
Radius. Is it number of pizzas?
No.
No, it's radius. So could I make a pizza with radius 1?
Yeah.
Could I make a pizza with radius 2.5?
Yeah.
Yeah, so this is going to be a continuous function. But is it linear? No. So this we would call just non-linear. Do you guys actually know what function family this does belong to?
Quadratic. I mean,
I can't.
quadratic.
It's half of a quadratic. Why is it only half of a quadratic?
Because it's not like totally.
But why?
It looks like half a U.
No. Why do I not have the other half of the quadratic there?
Oh, because we're only looking at.
Can you have negative radius? So this is just the positive part of our quadratic. Okay? So on your homework, which is, so what do you guys notice? Looking back at the 2.2 notes, just really quick. When we were looking at our y coordinates, we went 14, 16, 18, 20. What are we adding each time? 2. What did we multiply x by?
2.
Okay? Looking at problem 2, we went from 512 to 509 to 506. What were we doing each time? Minus 3. And look at our equation. It was negative 3. So, are we adding the same number every single time here? No. So it's not linear.
You have the extra.
Okay?